Welcome you all to the week 7 tutorial of multivariable calculus. Myself Guru Bachan from Department of Mathematics, IIT Jodhpur. I am working in the broad area of fractal geometry and dynamical systems. I am the tutorial assistant of this course. Today we are going to learn some illustration that are based on normal vector, potential field, gradient, curl, divergence and their properties, and also line integral and their application. So I am starting with the question number 1. Find out the potential function for the vector field f is equal to 4xy plus y square z I cap 2x square plus 2xyz plus z square g cap plus xy square plus 2yz k cap. So we have given our vector field f in the following way, and we have to find out the potential function corresponding to this particular vector field. Try this one. Anyone home? Anyone find it? So in order to find out this particular potential, yes, please. Someone is saying something.
Sir, wait for a minute, sir. It's
Okay,
trying.
okay. I'm waiting.
The answer is coming 2 square y
Yes,
plus xy square z
yes.
plus yz square.
And is there no constant involved in this particular?
Sir, plus constant. Right.
Yeah, plus constant.
2x square y plus xy square z plus z square y plus c.
Yes, correct. So let me write it here. So for in order to find out the potential function, let phi be the potential function corresponding to the vector field f. Okay, so if phi is a potential function, that means f can be written as gradient of phi, which is del phi by del x I cap plus del phi by del y j cap plus del phi by del z k cap. So this is our f by the definition of gradient, and we know that given value of f is this particular. So we can generate one more. Yeah, we know that this is our value of f, which is equal to this particular. So how we can relate it? We can say that del phi by del x will be equal to 4xy plus y square z. You can write this by comparing both the sides. So for simplicity, let me write it here. This is equal to this particular. So since have partially derivate this particular phi, and we are getting the value 4xy plus y square z, then we have to integrate this particular both the sides with respect to x. Therefore, we can say that phi xyz will be nothing but integration of 4xy plus y square z with respect to x, plus since we are integrating with respect to x, and we know that when we are differentiating, partially differentiating a function of several variables, then we treat the other variables as constant. So here the other variables are y and z. So we get the constants in term of y and z. So by integrating this, we can get 2x square y plus xy square z plus phi 1 yz. Now we are willing to find out this phi 1 yz. To find out this, we can again compare del phi by del y, which is equal to this particular quantity. So we have to partially differentiate this phi with respect to y. That means x and z are constant. So it will give us 2x square plus 2xyz plus del phi 1 divided by del y. Since it's a function of y and z, so we are writing it as del phi 1 by del y. Now, what is the value of del phi 1 del phi by del y? It is 2x square plus 2xyz plus z square. It is 2x square plus 2xyz plus z square, which will be equal to 2x square plus 2xyz plus del phi 1 divided by del y. Now comparing these two quantities, we will get del phi 1 divided by del y is nothing but z square. Now we are knowing that this phi 1 differentiating this phi 1 with respect to y, the answer is z square. So after integrating, it is a function of y and z. So this z square will be integrated with respect to y, plus there will be a function of z, since z we are treating z as constant. So this will give us y z square plus phi 2 of z. Now we want to calculate this phi to z. To calculate this phi to z, we can use this del phi over del z quantity. For that, we have to first write it in the form of phi xyz. So we know that phi xyz was 2x square y, 2x square y plus xy square z, and now yz square plus phi to z. So with differentiating both the side with respect to z, we will get xy square plus 2yz. Now since it is a function of single variable, so we can write it phi 2 dash with respect z. Now comparing this particular with this, we get xy square plus 2yz. So put this value here, xy square plus 2yz will give us xy square plus 2yz plus phi 2 derivative with respect to z. From here, we will get phi 2z will be equal to 0 and phi 2z will be some integration 0 dz plus some constant. And we know that in case of single variable integration, there will be addition of constant. So this will give us C. From here, we can conclude that phi x y z is nothing but 2x square y plus xy square z plus yz square plus constant. Okay, any doubt? Okay, yes, please.
Is that curl f is 0?
I will let you know. Let me start with in my way. Okay, I will
Uh,
discuss that. I will
if
discuss that part. I am
curl f
saying,
is not equal to 0.
I have
So therefore,
prepared.
f cannot be a potential function.
Okay. Any other suggestion? So we got our phi x, y, z. Now we can cross verify it by differentiating by calculating its gradient. So why I am doing that, we will get to know in the next question. So while calculating its gradient, we will differentiate this phi x, y, z first of all with respect to x. So we will get 4xy plus y square z I cap. Now, with respect to y, it will give us 2x square plus 2xyz plus z square j cap plus 2x. With respect to z, it will be 0. So, it will be xy square plus 2yz k cap. And this is exactly our vector field f. So we can say that we have find out correct gradient function that we required to find out. So let me give you another glimpse by a second question. So in this case again, find out the potential function for the vector field f equal to xy minus y to the power 4 I cap plus x square minus 3xy cube j cap. So we have given this particular vector field and we have to find out a potential function corresponding to this vector field. Try this one.
Another function not exist.
Not exist. Okay.
Yes, sir.
Any other answers? I mean, different answers. Okay. Let us try it here. So, first of all, let us assume let phi be the potential function associated to the given vector field f.
So
So
does
that,
not exist
yes, correct answer.
because we are unable to find the constant.
Okay. So this will be del phi. So since here we are working in two components, so it will be del phi del x I cap plus del phi del y j cap. And we have given our function in the particular form. So from here, what we can say that, so from here we can compare and we can get del phi by del x as xy minus y to the power 4, and which will imply our phi xy to be integration xy minus y to the power 4 dx plus phi 1 in terms of y. So from here we will get x square y by 2 minus xy to the power 4 plus phi 1 derivative of y. So next task is to, sorry, here will be phi 1 y. Next task is to calculate this phi 1 of y. So differentiate with respect to y both the sides, and we will get x square by 2 minus 4xy cube plus phi 1 derivative of y. And from this equation, we can say that del phi by del y is equal to x square minus 3xy cube. So from here, x square minus 3xy cube is equal to x square by 2 minus 4xy cube plus phi 1 dash of y. From here, phi 1 dash of y is equal to x square by 2 plus xy cube. Now we have to integrate this particular one with respect to y. So we will get x square by 2 plus xy cube, integrate it with respect to y plus some constant, which will give us x square y by 2 plus xy to the power 4 plus constant. Now put this value into phi xy. And what is phi xy? Phi xy was x square y by 2 minus xy to the power 4. X square y by 2 minus xy to the power 4. So this will give us plus x square y by 2 minus xy to the power 4 plus c. So I am doing correctly. Is there any calculation error or something? Anyone can suggest in between. Okay. So from here, there is a calculation x y to the power 4 by 4. So this will give us this, which is x square y minus, this is plus,
Sir,
yes, please.
how you got sir phi 1 y, sir? How you are treating sir x, the function as constant, sir?
I am treating, see, here it is a derivative with respect to y.
Yes, sir.
Okay. So suppose I am telling you, suppose this is the output. Okay. Now differentiate this with respect to y. Will you get this or not? So you want to say it cannot be a function of x. You want to say like that?
Yes, sir. This is the sir the case, sir.
Okay, I agree to you, but I am just letting you know some different glimpse. Then maybe conclude in a different way. Okay, we will
But long,
conclude.
long we are getting here the contradiction.
Wait. I will give you contradiction by a three way. Okay, let me just complete. Okay, so this will give us 3 by 4 xy to the power 4 plus c. So for the time being, we assume that this is our phi function. Now calculate its gradient. Its gradient will give us x square minus 3 by 4 y to the power 4. Sorry, here with 2xy I cap plus x square plus 3xy cube j cap, which is not equal to our f. So that means there should be any mistake we have done, or you can say that the phi function does not exist. The one reason is directly from here, that phi 1 is a function of y. So we can say directly that it cannot involve x. Yes,
So first we'll have to check whether curl f equal to 0 or not.
Muttu Kumarji,
If
let me explain the things in my way. Then after that, you can get your conclusion as it is. Sandeep ji, please don't react like this, please. So here, phi 1 derivative of is a function of only y, and it is involving x in this. So we don't need to even integrate after this. Okay, this is I am telling you when you are assuming that our field has some gradient, or you can say our field has some potential function. Okay, the another thing is that we are not getting del phi is not equal to f. Okay, now the last thing is that how we can be assured that our potential function is going to exist or not, so that we can get rid of these all calculation. Okay, so that we can obviously guarantee that there exists a potential function corresponding to our vector field. So for that, we need to calculate the curl of a vector field. So I have done both of the question without mentioning that curl is zero or curl of a vector field is zero, because I want to give you a glimpse that you don't need to go with this harder calculation without knowing the existence of the potential functions. So it's just a bluff to make you understand that how we should calculate, or in which case we should calculate the potential function corresponding to the vector field. So now let me define.
Sir,
Yes,
sir, is your integration valid, sir?
what?
How did you proceed, sir, from 5 dash y to 5
I already told you that there are three reasons. One reason is this, that we don't need to proceed after this. One reason is this, that this del phi not equal to f, and the smarter way is to first calculate the curl f. So I have told you three reasons not to getting the existence of a potential function corresponding to this given particular vector field. Okay. So your reasoning is correct. I am not telling you that is wrong. I am just telling you, I am just trying to get to this particular step so that I can also show you that del phi is not equal to f. You are correct. We don't need to proceed even after this. Okay. So let f x y z is equal to f1 x y z I cap plus f2 x y z j cap plus f3 xyz k cap be any vector field. Then we say that there exists, okay, let me write it. there exists a potential function corresponding to this particular vector field f if and only if curl of f is zero vector. Okay. Now the question arises how to calculate curl in if we have this three components and we have two components. So for that, curl of f, if we have these three components, then we calculate like this: I, j, k, del by del x, del by del y, del by del z, f1, f2, and f3. So we need to calculate this and to show this that this curl f is going to 0 in order to get the existence of this potential function. If this not equal to, if this will not equal to 0 vector, then we can guarantee that there does not exist a potential function corresponding to the given vector field. Now if suppose we have f is like this f1 x y z I cap plus f2 in fact x y j cap, and this can be written as f x y. So in order to calculate its curl, we can say that curl of this particular f is, or you can say that you can directly show del f1 by del y is equal to del f2 by del x. So curl is nothing but of these two variables del f1 by del y minus del f2 by del x. Since it is going to 0, so I am just reducing the condition to show that this equality hold or this condition hold so that our field is conservative. So let us find out curl of f for the first question and in fact for the second one also. So let us just copy this equation. So this is our given f for the first question, and we need to calculate its with respect to this its curl. So del cross f, it is equal to I cap del by del x 4xy plus y square z. Next one is j cap del by del y 2x square plus 2xyz plus z square. K cap del by del z xy square 2yz. So calculate this value. So this will, first of all, we have to differentiate this with respect to, partially differentiate with respect to y. So this will give us 2xy plus 2z. This with respect to z with negative sign 2xy minus 2z minus j cap. Now for the j cap, we have to leave the second column and we have to calculate this with respect to x. So it will be y square plus 0 with negative sign from here with respect to z, 0 minus y square. Next one is k cap. So this will be 4x plus 2yz minus 4x minus 2yz. So clearly we are getting this curl is as a zero vector. So that means for this first question, we can guarantee that we have a potential function corresponding to this particular f. Okay. Now, same we have to check for the second one also. In the second question, this is our given vector field. So for this vector field, we need to apply the del f2 by del y, del f1 by del y is equal to del f2 by del x. If it is not equal, then we can guarantee that the corresponding potential function with respect to this does not exist. So let us calculate what is f1 xy here, xy minus y to the power 4. f2 xy here is x square minus 3xy cube. Calculate here del f1 by del y, which will x minus 4y cube, while del f2 by del x is 2x minus 3y cube. Now clearly from this 2 you can say that del f1 by del y is not equal to del f2 by del x. So we can say that our given vector field is not conservative, or you can say there does not exist any potential function corresponding to this vector field. So from now onward, you have what you have to do for in any given question, whether they have told you that to find out a potential function, you should first check the curl of this f. If curl of f is a zero vector, then you proceed, or you can guarantee that potential function of that particular vector field exists, and then you can try to find out what is the value of the potential function. That's what I want to let you know from these two questions. Okay. Now let me move to the third one. You have to examine which of the examine, you can say examine the solenoidal field out of the following. So I'm writing the first one first, then we will solve it, then we will write the another one. So F1 is F1 xyz is equal to x plus y I cap plus 2y minus 3z g cap plus 3x minus 4z k cap. Check whether this field is solenoidal or not. Check it. Okay, your answer is correct. Any other?
Not.
Okay. So how we can check the field is solenoidal? Like what is the definition of a solenoidal vector field? A vector field F is solenoidal if del dot F is 0. We can say that divergence of this vector field is 0. So divergence of a vector field is a scalar quantity or a vector quantity? First of all, tell me that. Divergence of a vector field, scalar. Why? Since we are doing dot
Dot
product,
product.
yes, right. We are doing dot product of this del operator with given vector field. So it will give us scalar. So calculate here del dot f1. So del dot f1 is del by del x of x plus y plus del by del y of 2y minus 3z plus del by del z of 3x minus 4z. So this will give us 1 plus 2 minus 4, which is minus 1, which is not equal to 0. So the given vector field, this F1 is not solenoidal. So I am writing this directly, not solenoidal field, or you can say that not solenoidal vector field. So not solenoidal. Okay. Now let me write another function f2 x y z equal to x minus y I cap plus 2y minus z j cap plus 3x minus 4z k cap. Whether this is a solenoidal vector field or not, right?
No, sir.
No. So again, we will calculate its divergence, that is del dot f. So del dot f will be del by del x, x minus y, del by del y. I hope you will understand. I have skipped here one step, the del operator and dot product with this f. So I'm just applying del by del x over this first component, del by del y with this second component, and del by del z with the third component, that is 3x minus z. So this will give us 1 plus 2 minus 4, which is equal to again minus 1. Okay, which is non-zero. So that means not a solenoidal vector field. So for two parts, we get to know that these two are not a solenoidal vector field. Now what about the third one? See, F3 xyz is equal to 2x minus 2y I cap plus 2y minus z j cap plus 3x minus 4z k cap. Try for this. Okay, you are quick.
Solenoid.
Okay. So this one is solenoidal. The reason is, again, we have to calculate divergence of this. So this will give us del by del x of 2x minus 2y plus del by del y of 2y minus this z, del by del z of 3x minus 4z. So this will give us 2 plus 2 minus 4, which is 0. So that means F3 is a solenoidal vector field. Okay, so that means whenever we have to check whether a given vector field is solenoidal or not, we just need to check its divergence, whether its divergence is zero. If its divergence is zero, then we can say that given vector field is solenoidal. Otherwise, it is not a solenoidal vector field. Next one is somewhat related to this gradient part. Calculate the value of gradient of 1 by r, and here vector r represents x I cap, y j cap, and z k cap
minus r upon r cube.
minus r upon r cube. So you haven't mentioned minus r is a vector or r cube is a
Minus r is a vector in numerator,
and denominator.
scalar.
Okay. Any other answer? Yes,
It's the minus r by r cube.
minus r. Okay. So what is gradient of, first of all, for which field we can find out gradient, scalar or vector? For which quantity we find out gradient? Yes,
Scalar.
scalar. So suppose phi is any scalar function. So grade phi is del phi by del x I cap, del phi del y j cap, del phi del z k cap. Here phi is a scalar function. Okay. So from here r means under root x square plus y square plus z square, and our given phi is 1 by r. Okay, so we need to calculate first of all del phi xyz is 1 by r, which is again 1 by under root x square plus y square plus z square. So del phi by del x will be equal to, we have to partially differentiate this. So this is minus half. So we will get here minus half into x square plus y square plus z square to the power half plus 1 into, by chain rule, del by del x of x square plus y square plus z square. So this will give us 2x, and 2 will cancel out. This will give us x by x square plus y square plus z square under root to the power 3. So that means minus x by r cube. Okay. In a similar fashion, you will calculate del phi over del y, which will again give us minus 1 by 1 upon x square plus y square plus z square to the power 3 by 2 into 2y, which is nothing but minus y by r cube. And in a similar way, del phi by del z will give us minus z by r cube. Now we have to put all of these three values in the given definition of grade phi. So grade phi will be, or in fact here grade of 1 by r will be minus x by r cube I cap minus y by r cube j cap minus z by r cube k cap, which can be rewritten as minus x I cap y j cap z k cap divided by r cube. And we have already know that this is nothing but the vector r divided by its cube times of this magnitude. Okay, so next question is question number 5. Let we are given a vector u as minus x I cap plus y j cap plus z k cap, and the vector v is y z square I cap plus x z square j cap plus 2xy z k cap. So let me It will be like this. So now what is the next? If u and v are irrotational vectors satisfying the relation that is del dot u cross v plus f times del dot u plus u dot v is equal to 0, then what is the value of the function, or we can say this is a scalar function, scalar function f x y z. Try this one. We have given a vector u, we have given a vector v, and we have given that these two vectors are irrotational and they are satisfying a relation. So we have to find out from that relation, we have to find out what will be the value of this particular scalar function that is involved in the relation. Try this one. Try this one. I'm just coming back in 2 minutes.
Sir, the second term in left hand side is not clear, sir. Is it f times del dot u or f
Yes,
of
f times.
f times, na?
Yes,
So, sir, this is minus 2xyz square.
minus 2xyz square. Correct. Any other answers? So how did you do this?
Sir, I used vector identity, sir,
Vector identity.
or sir del dot u cross v.
Okay. So can we
Then
don't can we not do without using vector identity?
yes, we can do, but it will be easier.
Yes, correct. It will reduce our calculation.
Yes, sir.
So first of all, I will let you know one approach which does not involve any vector identity, so that sometimes it is not comfortable for everyone to remember that vector identity. It will take more time, but it will give you a understanding from that also. So what we have here, we have to first calculate this u cross v, and u cross v is I j k, and we have given that minus x, y, and z. And the other factor is yz square, x z square, 2xy z. So from here we will get I is 2xy square z minus xz cube minus j cap minus 2x square yz minus yz cube. Please check the calculation parallelly. Minus x square z square minus y square z square. Next task is to calculate its gradient, oh sorry, divergence, that is del dot u cross v. That means del by del x of 2xy square z minus xz cube plus del by del y of, this one is with positive sign, minus minus will become positive, 2x square yz plus yz cube plus del by del z of minus x square z square minus y square z square. So this will give us 2y square z minus z cube plus 2x square z plus z cube minus 2x square z minus 2y square z. Clearly, these terms will cancel out, this and this. All of this cancel out, and we are getting this quantity as 0. Now, what is the next term is del dot u and u dot v. So, del dot u is, our u was given that minus xi cap. So, del by del x of minus x plus del by del y of y and del by del z of z. So this will give us minus 1 plus 1 and plus 1, which is equal to 1. Now the third one is u dot v. U dot v means we have to multiply the each of the components, like I cap with I cap, j cap with j cap, and k cap with k cap. So here it will be minus x into yz square, y into xz square, or z into 2xyz. This will give us minus x into yz square. So this will be minus xyz square. The other term is y into xz square. So this will give us xyz square. And the last one is z into 2xyz. So 2xyz square, which will give us 2xyz square. So we have three terms involved in the given equation, this star, and we find out all the three values. First one is 0, this one is 1, and this one is 2xy z square. So from here we can say that 0 plus f into 1 plus 2xyz square is 0 from the given equation star. Now f x y z will be nothing but 2xyz. So this is the simple way to do the calculation directly. And the another way, if you will notice, that we have given that irrotational vector field. So what is the meaning of irrotational? Anyone?
There is no sense of rotation.
In
Curl
mathematical
F bar,
terms,
zero bar.
sorry, curl of f. So we say that since we have given that u and v are irrotational, that means curl of u is zero vector and curl of v is also zero vector. Okay. Now, how can we apply this? Since in the given expression there is no term like curl of u and curl of v, but there is a term here del dot u cross v. So for that, we have to use one identity, that is del dot a cross b is nothing but b dot del cross a minus a dot del cross b, or in fact you can write it like this: del cross a dot b minus del cross b dot a. So we need to use this one. So from here, del dot u cross v, we will get del cross u dot product with this v vector minus del cross v and dot product with u vector. And we know that this is 0, and 0 dot product of 0 vector with any other vector will be 0. So this quantity will be 0. So we have reduced a very much calculation of this particular one. I just let you know this one because sometimes we don't remember the exact vector identity, so that we can also calculate like this. So from here you have get this quantity as 0, and you know you have also calculated del dot u is simply 1 and u dot v is simply 2xy z square. So again from star you can directly say that f x y z is equal to minus 2xy z square. So these are two ways to calculate this function, scalar function. One is a little harder way and one is a smarter way. So the my question from here is, can you guarantee that I have wrote here that I can like shift their dot product like commutativity. So can you guarantee that A dot B is equal to B dot A for all A comma B? Can you guarantee this one?
Just that this should be true.
Okay. If that is so, what about this one? Del dot A del A dot del.
Not correct, sir.
Okay. So what will be the difference?
Sir, del is an operator, sir.
Good. Here del is an operator, and here we are discussing of any two vectors. So if you will multiply by taking suppose A as A1 I cap plus A2 j cap plus A3 k cap and B as B1 I cap plus B2 j cap plus B3 k cap. When you find out the dot product in both the way, then you will get to know that these two quantities are equal. But while you're talking about this one, the answer will become no. The reason is here we don't have exactly a vector. It is a vector, but it is an operator also. So in case of this del dot A, what you will get? You will get del of A1 divided by del x, del of A2 divided by y, del y, del of A3 with respect to this z. And here I am assuming this vector as A1 I cap, A2 j cap plus A3 k cap. Okay. Now what about the other side? Other side will become this dot product is a some scalar quantity. So the other side is E dot del. So this is nothing but this will be an operator. E1 del by del x, E2 del by del y. This is a scalar quantity, but it is also an operator. But this is not an operator. Okay. So this was just a glimpse that this dot product is commutative for vectors, but not for vector and operator, an operator. So let me write the next question, which will give you the glimpse of line integral. So find the value of the line integral f dot dr over c. Here the function f is x, y, z is equal to 2y plus 3 I cap plus x z j cap plus y z minus x k cap. Okay. And I am writing this. I will take two curves. First one is C is the straight line, in fact straight lines from 0 0 0 to 0 0 1, then to 0 1 1, and then to 2 1 1. So we are traveling first of all from 0 0 to 0 1 1, 0 0 1, then 0 1 1, then to 2 1 1. So we have three straight lines. This curve is divided into three curves, that is C1, C2, C3, and we have to calculate this whole value of the integral. Try this one. Can anyone suggest that how we will approach this one?
Sir, vertices are denoted with OA, B, C.
Okay.
We should calculate OA bar, line
Hmm.
OB bar, OA
Hmm.
bar, AB bar, BC bar.
Okay.
OA bar straight line equation is x minus 0 by 0
Hmm.
equal to y minus 0 by 0 equal to z minus 0 by 1 equal to some t.
Correct.
Parametric equations we have to
Yes.
consider.
Yes.
Then it will be integral over C, integral over f1 dx.
Hmm.
Just we have to replace those values
Hmm.
and then we have to obtain the solution. So
Okay.
such like that OA bar
So
and
you are
then
directly doing this integral, calculating this integral by dividing this integral into three subparts.
yes, sir.
Okay.
Yes, sir.
So
Yes.
I am suggesting was one thing. There can be one more smarter way. I am not sure. I am not claiming that this is valid in this particular case. Whenever you have given this kind of line integral, the first step is to check that whether the given field is conservative or not. And I hope you remember what is the advantage of being that vector field is to be conservative.
Yes, sir.
So if this
Conservative
vector,
means curl F bar is 0 bar, sir.
exactly. So curl f is
Exactly.
a gradient of f. So you can guarantee that there will be a scalar function. And what will be the benefit? That it is independent of path. So you just need to calculate its integral over the initial point and the final point. Okay. So whether it is valid in this particular case, it is not sure, but you should try first of all by calculating curl of f. Yes, Sandeep ji, you were saying something?
No, sir.
Okay. So first of all, calculate its curl. Till then, I am writing the thing that I have said to you. Kindly mute yourself, whosoever um, is my call. So first of all, focus here. Then I will ask something. So if f is conservative, then we can say that f is in this integration will be independent of path. That means whether you will focus from this C1 path, C2, C3 or C4. I'm just changing that these all are C's kind of. So whether you will follow this path or this path or this path, this all from all the path, the integration will be the value of this integration will be the same. Now the question arises, how? So the conservative means it will give you as gradient. F will be nothing but del phi. So in order to check this, first of all, it is conservative or not, you have to calculate curl of F and it should be a zero vector that we have done in the earlier question. So our primary task whenever we see this line integral, just to check whether the this vector field is conservative or not. If, excuse me, if this is conservative, then we can say that this line integral is directly equal to the this value of the final point at this putting the value of final point in this conservative function, or you can say scale or potential function, and minus that potential function value at the initial point. So it will sometimes reduce your maximum calculation. So anyone has calculated its curl? Anyone has calculated its curl?
16 by 3.
Sorry.
16 by 3.
Okay. Its curl will be, let me calculate it. I'm not able to find it. Curl of F, this will be I cap, J cap, K cap. So this is 2y plus 3 xz, 2y plus 3 xz, and the other one is yz minus x. So
Sir, I
this
am
will,
telling you the answer.
sorry,
I'm telling you the zero.
yes, what is the answer?
16 by 3.
Sorry, you are not audible properly.
16 by 3.
No. So I cap from here, we will get z minus x minus j cap minus 1,
0. This is 0.
0, k cap z minus 2. So this will be not a zero vector. So from here you can say that this f is not conservative. So f is not conservative. Therefore, you have to follow that approach of finding out the straight line. So you will divide this integral f dot dr equal to c1 f dot dr plus c2 f dot dr plus c3 f dot dr. And what is c1, c2, c3 represent? C1 is the curve. It is a straight line from some point O 0, 0, 0 to the point, a second, answer 9 maybe, no, 9 is not a correct answer. The point A is 0, 0, 1 and C2 is another straight line from A 0, 0, 1 to this B 0, 1, 1 and C3 will be a straight line from this B 0, 1, 1 to some point C from 2, 1. Okay. So you need to first of all calculate this parameterized vector form or a Cartesian form of this straight line. So let me calculate. C1 is some RT. We know that RT is the starting vector plus T times B minus A. I'm writing this because we have to again compare XT and YT and ZT. So it will be easier for us. So this will be 0 y cap. Please mute yourself, Sandeep. 0 j cap plus 0 k cap. This is our vector A. I am just writing for the clear view. So this one will be 0 minus 0 y cap plus 0 minus 0 j cap plus 1 minus 0 k cap. So from here we will get our vector to be only t times k cap. Okay. So that means our xt is 0, our yt is 0, but our zt is t. And this zt will imply dz to be dt, and dx will be 0 and dy will be 0. So our integration of this over this C1 f dot dr will just reduce to the third term, that is C1. So our function was, right, what is the function?
Sir, it is coming out to be 0.
Okay, but I have to write it, no?
2y
Explicit.
plus z,
Yeah.
2y plus 3 I cap.
Okay. So 2, we will not write 2y plus 3 because 2 times of 0,
Yes, sir, plus
because y
3.
is 0. I
Yes, sir.
kept your answer is correct, Om. It is 10. So
Plus 0 j cap
plus 0 j cap plus
plus 0 k cap.
0 k cap. Okay, because y is 0, x is 0, so it xz will be 0, and from this yz will be 0 and x is 0. With dot product with dr. What is dr? 0 y cap plus 0 j cap plus dt times k cap. So since this dot product will comes out to be, this is 3 but this is 0, so it will give us 0, this is 0 0, again 0, and dt will be 0. So this integration will be nothing but giving you value 0. In the similar way, what is the equation of this straight line?
This is
Sir,
tj cap.
Excuse me, sir.
Yes, please.
Tj cap.
sir, we can take symmetric form also, sir.
Yes, so we can
X
take
minus.
symmetric form also. Nothing. It will
Okay,
give the
sir.
same now. Xt will be 0,
Same.
y. I'm
Yes,
just
sir.
avoiding this. Maybe someone will like ask like why you're writing x by 0 is equal to t is equal to
Yes,
x
sir.
equal
It
to
is
0.
simple.
So I'm just
Yes, sir.
avoiding that, and so it will be more clearer to you in writing this particular form. Okay.
Okay, sir. Thank
So otherwise I have to recall that concept first. So I have some other question to make give you. Okay. So yeah, you were saying something, Sandeep. So this will be 0 I cap,
tj cap.
okay, 0 j cap and k cap plus t times of, it was 0 minus 0
0
I
1
cap
0.
and 1 minus 0 j cap plus 1 minus 1 k cap, right? So this will give you k t times j cap plus k cap, right? You were saying this. So from here xt will be, I am writing step by step. The reason is because then you will get to know how to calculate this line integral. So this will imply dx to be 0, dy to be dt, and dz to be 0. So from here, this f dot dr over this C2 will be integration of this C2 2 times of y, that means 2 times of t plus 3 I cap plus, next one is x into z. So x into z, x is 0, so that means x into z will be 0. The third term is yz minus x. So plus yz. Y into z is t minus x is 0, k cap. And dot product this with 0 y cap, since dx is 0, plus dt j cap plus 0 times k cap. So from here, our first term is 2t plus 3, but here is 0. So it will give you 0. Here it is 0, it is dt. So it will again give you 0. It is t minus t, or it is 0, again 0. So again this integral contribute as 0. Now the last part is third C3. So we are joining 0, 1, 1 to 2, 1, 1. Okay. So from here, 0 I cap, j cap plus k cap plus t times 2 minus 0 I cap 1 minus 1 j cap plus 1 minus 1 k cap. So this will be our equation of straight line in 3D. So this will be 2t times I cap plus j cap plus k cap, right? So from here, xt will be 2t, which will give you dx as 2 times of dt. Next one is yt is equal to 1, which will give you dy is equal to 0, and zt is equal to 1, which will give you dz is equal to 0. So integral over f dot dr over this straight line C3 will give you 2 times of y, that means 2 times of 1 plus 3 times I cap, plus next one is x into z. So x into z is 2t j cap. So x into z is 2t plus y into z, that means 1 minus 2t k cap. Dot product of this with 2 times of dt I cap 0 j cap 0 k cap. So again third and second and third component will give us 0, and this C3 can be reduced to 0 to 1. So in this equation we can write 0 to 1. So we can also correct the same in the above also. So 0 to 1, again 0 to 1, t lies between 0 to 1. So this C1 curve is nothing but 0 to 1 integration. Okay. So from here you will get t 0 to 1 5 into 2 times of dt, which will be 10. Now the correct answer is 10. There were several answers, but the correct answer is 10. Okay, I hope everything is clear in this particular question. Now I am just changing the curve slightly. The straight line, now I am saying that C is the straight line from 0, 0, 0 directly to 2, 1, 1. So this will also give you one glimpse, but I will let you know once you will complete this one. Okay. Try this one. So in the earlier part, we have not concluded this properly, that CF dot dr was the addition of the integral over FD dot dr over these three curves. So this will be 0 plus 0 plus 10. So what have done in the first part, we have divided our curves into, or straight lines into three parts. We have given a piecewise smooth curve, you can say that. Now here we are directly talking about, we are directly going from 0, 0 to 2, 1, 1 rather than going from 0, 0 to first 0, 0, 1 or 0, 0, 1 to then 0, 1, 1 then to 2, 1, 1. So I am directly going from this to this. Let us see whether the answer will change or not. First of all, from my above explanation, can you guarantee that answer will change or it will not change? I have given you one explanation here. I'm giving you the hint also. Tell me. Yes.
So it is not conservative, so it may be
Good,
so.
good. Since it is not conservative, so it will depend on the path what we follow from the initial point to the final point. So answer will definitely change. So
So it
calculate.
is coming out to be 3.
No, that is not 3. Do it again. So what will be the equation of the straight line here?
Sir, 5.
Sorry, 5.
Hmm.
Again wrong. Will you please do calculation in a good way? So it is 0 I cap, 0 j cap, 0 k cap
Sir,
plus,
8.
yes, 8 is the
Yes,
correct
sir, yes.
answer. So it is 2 minus 0 I cap, 1 minus 0 j cap plus 1 minus 0 k cap. Okay, so this will be 2t I cap, t j cap, t in the direction of k cap. So from here, xt will be 2 times of t, which will imply dx to be 2 times of dt. Similarly, yt will be t, which will imply dy to be dt. Zt will be t, which will imply dz to be dt. Okay, now directly we have to calculate, since there is only one straight line, that we directly calculate this integral over c. So this will be t0 to 1. So it will lie 0 to 1. So 2 times of y plus 3. So 2 times of y is 2 times of t plus 3 I cap minus. No, 20 is not a correct answer. 8 is the correct answer. So just a second, please. So the next term is minus y plus xz. So x into z will be 2 times of t square j cap plus yz, that is t square minus x, that is 2t k cap. So this is our f, and what is our dr? 2 dt I cap plus dt j cap plus dt k cap. So this will give us 0 to 1, 4t plus 6.
Answer the 9, sir.
No, 9 is not a correct answer.
Okay. Okay.
Yes, 2t square plus t square minus 2t into dt. So this will give you, on simplifying, 0 to 1, 3t square plus 2t plus 6 times dt. So is there any mistake, or the I have done correctly? Anyone? So let us integrate it. T cube plus t square plus 60, 0 to 1, 1 plus 1 plus 6, 8. So this is the correct answer that got in. So what is the benefit to write all the things explicitly, that there is a less possibility of getting an error or getting the wrong answer? As you have also seen that there were many different answers. So there might be the reason that we have made some integration error, or we have not write the things in explicit way. It Writing in explicit way would take some time, but it will guarantee you the correct answer. Okay. So I hope it is clear that when since the field is not conservative, so changing the path will obviously uh, lead to the different answer over of the line integral from uh, same initial point to the same final. Okay.
Sir, how can we define T limits, sir? So
Okay.
can,
Okay.
sir,
So see here, we
the
are
point,
moving. Yeah. Let me explain,
so
please.
the point T satisfies both the points and parametric
Exactly,
equations.
exactly, exactly. So it
Okay, sir.
should satisfy both the points. So it will start from 0, 0 and it will go to 2, 1, 1. So since I'm at, observe from here, I'm adding this initial point plus t times of something. So if you want to start with this, t should be what?
Start with 0, T with 0, sir.
Okay, t will be 0 so that you can start with the straight line with this point. Okay, now
Okay,
you
sir.
want
Okay,
to end up with this point. So suppose if you this is a times a plus t times of b minus a. Suppose you will take here t as 1. So what it will give you?
T is 1, sir.
Okay, so t equal to 1 will give you the another point, that is a final point, that is b. So that is why we
Okay,
write in, it is a general form. So you can directly obviously say that t this will be for this also, t lies from 0 to 1. Okay.
okay, okay,
So
sir.
t equal to
Thank you.
0 stands for the initial point of the straight line, and t equal to 1 corresponds to the final point of the straight line in 3D. Okay.
Okay, sir. Okay, sir. Thank you.
Yeah. So the next question number is, let me see first of all. This is sixth one. Now the question number 7. So there is another line integral. Find the value of the work done by the force F is equal to minus xy I cap y square j cap plus z times k cap in moving a particle from 200 to 020 over the circular path x square plus y square is equal to 4, comma z equal to 0. So you have given a force field and you have told that you have to follow a circular path from 200 to 020, and where z is 0. So we have to find out the work done, and work done is nothing but line integral of f dot dr over this particular curve. So try it.
Sir, same as above, sir. Just we have to take the
Hmm.
parametric equations and then we have to x is a 2 cos theta, y is a 2 sin theta.
Okay, and then what would be the value of t
What
here?
will be 6
That is
sin
the
theta?
crucial point. Earlier, we can directly say t from move from 0 to 1, but what will be the value of t? in this particular case.
From 0 to pi by 2, if we take
Right,
theta.
right. So let us start here. In between, you can also let me know what will be the exact answer. So since we have given this circular circle in this xy plane, we can draw it. This is 2, 0. I'm just drawing in xy plane, so that's why I'm writing 2, 0, and z is 0. I'm assuming in xy plane z is always 0. Okay. So from here, x square plus y square is 4. What is the parametric xt? This will be 2 of cos t, and yt will be 2 of sin t. And we have given z to be 0, so we can take z to be directly 0. So from here, you can say that dt will be minus 2 times of sin t dt. From here, dt will be 2 times of cos t dt. Since we have taken this kind of polar thing, so this will go to this 0 to this pi by 2. T will be 0 to pi by 2. Since we are moving from here to here, that is why it is 0 to pi by 2. Suppose we have this direction, so the answer will be, what will be the pi by 2 to
Pi by
0?
2 to 0.
Good one. So assume that this is a circle. Where is it? So now C F dot dr. What is CF dot dr? This is the work done for moving the particle from the point this 200 to 020. So it is 0 to pi by 2. Now, what is the f in terms of this parametric? Minus xy. Minus xy means 4 times cos t into sin t with negative sign. Cos t into sin t I cap. The next one is y square. That is 4 sin square t j cap. The last one is z times k cap. That is 0 times k cap dot product with minus 2 sin t dt I cap plus 2 cos t dt j cap plus 0 times k cap. So from here you will get 0 to pi by 2, 8 times sin square t cos t plus 8 times sin square t cos t plus 0 dt. Correct? So this will be 16 times of 0 to pi by 2 sin square t cos t dt. So what will be the value of this? What will be the value of this integration? This is easy, right?
1/3, sir.
1 by 3. How? Yeah,
Sin t, if we put sin t is as x, cos t dt is dx,
right.
t
So
square,
we
limits
can,
has to be changed
limit has to be changed, but I can write directly like this.
directly. Okay, sir.
Okay. Since we are well aware about this, that difference, this is ft and this is its differentiation, so we can directly write this. So this will give us 16 by 3. So our integral, line integral, or you can say work done is 16 by 3 unit. Okay.
So here we can apply independent of path, sir. Curl f bar, 0 bar. We are not testing here.
Yeah,
Is there
we
any
can
chance
we
to?
can check. We can obviously check here. So it
Okay.
might be that independent of path. We can check here also. Let us
Here
try.
also we can take a direct path, sir. F of phi of
Yeah,
yeah, final value minus phi of
if
initial value.
curl of f will give you the zero value, then you can take that directly. Phi of, you have to find out the gradient and that phi of that point minus that other point. Earlier, what is the ease? We have we are three straight lines, suppose from here to here, then here to here, then here to here, like this.
But
I'm
here
just drawing.
the path is circle now, sir. Circle.
First, let me
We
complete.
can use any path, sir. Is there maybe circle or straight line or
Right, right. So in
rectangle or
what is the benefit in that earlier case, that we have to calculate over C1, C2, C3. If the field is conservative, we can directly calculate this conservative and we can just put this final point minus
point?
initial point. But here we have given only one path. So again, if you have to calculate that it is conservative, then that you have to calculate potential function, then you will put the value. So it will give you a kind of a same calculation, that same effort or same time consumption. So or we can also, if we have given us some, suppose two or three paths connected, then we this will be good for us to first check this one. Still, we are trying that to check this given vector field is conservative or not. So minus xy del by del y of. By the way, the good question you have asked.
Sir, minus
Thank you,
k,
sir.
x k cap.
Okay, good. Z. So you have checked earlier or you checked after saying
No, sir,
my
I have checked it earlier.
earlier? Good.
Yes,
So this will be 0 minus 0 minus j cap. This will be again 0
0
minus.
minus 0.
Why 0? This will be x now.
Yes, sir.
Yeah.
Minus
This is,
jx
this will be
is 0.
okay. Okay. Just a second. J cap. So it will be 0 minus 0. Right. You are right. I just put it here. So k times 0 minus 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 plus x. Right. X times k cap. Is this so?
Yes, sir. Yes, sir.
Okay. So clearly this is a non-zero vector. So that means
Non-zero.
f is not conservative. So don't need to find out a potential function, or we cannot have, we can say that it does not have a potential function. Okay. So let me write one question related to some properties of, you can say, gradient or divergence. Question number 8. If the vector field f is given as x square y square plus 3 times of z square I cap plus x square z plus 2y square j cap plus xyz k cap. Then find the value of grade of divergence of f at some point p, that is 1 to 1. So this is an easy question. So I would expect from all of you to get the correct answer in the first attempt itself. Try this one. First of all, tell me whether this grade of divergence of phi will be a scalar quantity or a vector quantity.
Vector quantity.
Vector quantity. Good. Why?
Why? Because divergence of f is a scalar.
Right.
The gradient of scalar is vector.
Good. So find out his answer. Yes.
Sir, answer maybe 5i bar plus 13j bar plus 0k bar.
I told you to give a correct answer in the first attempt.
Sir,
So
divergence, first we have to find the divergence, sir, and then we have to apply gradient.
you are correct,
Divergence,
but your
if
answer is
one,
not correct.
not
Your
correct, sir.
approach is correct, but answer no. Now you have lost the chance. Any other one will say for this particular one. See, it's an easy question. Like you should know, and you should not avoid this calculation mistakes in this kind of question. Correct.
10, 13, 0.
Correct.
Yes, sir. Yes, sir. 5 mistakenly, sir. Okay, sir.
That's why I told you, na, in the first starting that you should answer in first attempt. So
Okay, sir.
del dot f. What is del dot f? Divergence of f. So del by del x of x square, y square, 3 z square I cap will not be here because since it's a divergence. Del by del y of x square z plus 2y square plus del by del z of x y z, which will give us 2xy square plus 4y plus xy. Okay. Now grade of divergence of f will be del by del x of this particular quantity. So I would write directly. So del by del x will be 2y square plus y I cap plus 4xy plus x plus 4 j cap plus 0 times k cap. Grade of this divergence of f at point 1 to 1 is when you put 2 in this particular value, so it will be 2 to the 4 to the 8 plus 2, 10 I cap plus 4 to the 8 plus 1 9 plus 4 30 j cap plus 0 k cap. Okay, so this is the correct answer. Please If you remember, I guess question number one of assignment six, it's not valid for that calculation. There is some error in this question, I think. There is a comment like that. It's not for evaluation. First confirm me that, then we can talk about it. I mean. So question number nine, number nine is let we have given a vector v x square plus y square I cap y square plus z square j cap z square plus x square k cap be a vector field, then the value of, or you can say, then find out the value of vector h, that is del of del dot v minus del square of v at point p 1, 2, minus. So we have to find out the value of this vector at the point 1, 2, and minus 1. First of all,
So here we should use vector identity, sir.
why?
Del cross V.
Yes.
Del curl of curl V bar is
Okay.
del of del dot V bar minus del square V bar.
Okay.
So left hand side, if we compute, we can get easily answer, sir.
Okay.
Curl V bar.
You want to say,
First we have to find out del cross V
yes,
bar, and then
tell me
again we
that
have to evaluate
identity. Del cross
V bar.
V bar, vector V.
So
So this is equal to H, you want to say, right?
H. Yes, sir.
Okay. That means we have to calculate the curl two times. Okay. We will check this. First of all, let me know that here I have written a vector over it and I have not written vector over here. Why? Is there any specific reason or I am
Sir,
just
del dot V is a scalar.
hmm. I am saying when I am writing only one del, then I am writing over its vector. When I am
So
writing
del
del,
square simply means del dot del.
yes. So it will give you a scalar quantity or scalar operator. Okay. That is why I am
Answer
yes.
2i bar plus 2j bar plus 2k bar, sir. Answer
Okay, let me check. 2i bar.
2i bar plus 2j bar plus 2k bar.
No, not a correct
No, sir.
answer. Again, you did the same thing. So I am trying to follow your approach. I am not sure whether this identity is true or not. So let us check first. I del by del x square plus y square, j del by del y square plus z square, k del by del z. So this will give you I 0 minus 2z minus j. So this will give you 2x minus 0 plus k 0 minus 2y. So this will be minus
So is this
2z.
zero?
Yes, sir.
No, no, it is not 0. 2x j cap minus 2y j cap. So again we have to calculate its curl.
Calculate. Yes, sir. Curl.
So this will be I j k del by del x minus 2z del by del y minus 2x del by del z minus 2y. So this will give you I minus 2 plus 0 minus j 0 and this will be plus 2 plus k minus 2 minus 0 minus 2y minus 2j minus 2k. So your
in assignment given minus, sir. So I have did the problem.
so I
So
had changed that column now. So
yes, sir. X square plus y square
I'm
I bar.
here to
X square. Yes.
tutor you. I'm here to teach you, so I can be a more some smarter. So here, what is the your identity? Your told identity is correct, absolutely correct. You can also approach from directly calculating this value and this value and subtract them. Otherwise, you can use the identity told by Mr. Abdul. This is the correct identity. You can follow this and again, I have got the answer in the first attempt. I don't know why you are guys are getting error in the first attempt. So this will be helpful in
Sir,
solving your assignments also. Yes, please.
sir, go to the question.
Okay. Yes,
Uh,
please.
First, let me know that both LHS and LHS is a vector quantity.
Yes.
Right side is पहला टर्म जो है
हाँ
वो तो
बोलो.
ग्रेडियंट है तो वो तो वेक्टर होगा
Right?
और और दूसरा टर्म मेरे ख्याल से स्केलर है.
No.
Vector.
Vector. The reason is I am telling you this del square is a scalar operator, right?
यस सर.
And
Laplacian operator.
Laplacian operator. So we are applying this Laplacian operator to a vector. So I am telling you how it will work. Suppose V is some V1 I cap, V2 J cap plus V3 K cap. So this Laplacian operator over this V will work as this Laplacian of V1 I cap, Laplacian of V2 J cap, Laplacian of V3 K cap. Okay, so it is a vector quantity. If it is not a vector here, then you can say that it is a scalar quantity. Okay, any doubt on regarding this particular one?
Doubt cleared.
Okay. So I hope I think time is up. So this question will be enough for today, or else I can give you one more related to your line integral. This will be our last question. Question number 10. Find out the value of integral a dot dr over this C, and C is a closed curve, and here A is 3x square plus 6y I cap minus 14yz j cap plus 20x z square k cap, and our curve C, it represents a curve from 0 0 to 1 1 1 by x is equal to t. The parametric form is given as t square, z is equal to t cube. So let me correct it. This is not a closed curve. This is a straight line. So straight line of the different curve. So you have to move to from 0 0 to 1 1 1 along this path. So first of all, the primary task is to check this curve or directly you can also integrate. It will also be easy because a dot r, you have given a, you just need to put the value of x, y, z and the value of dr, and t will vary from 0 to what, Abdul?
T equal to 0 to 1, sir.
Good, t equal to 0 to 1. So try this one and I hope you will get the correct answer in the first attempt. So try this one. This will be the last question of today's lecture. I mean tutorial. Try it. I'm also doing in parallel. Dx will be
Five,
yes.
sir, answer.
Good. Correct this time. First attempt.
Thank you,
So,
sir.
so here will be 9t square minus 28 t to the power 6 plus 60 t to the power 9 dt. So this will give you 3t cube minus 4 times t to the power 7 plus 6 times t to the power 10, 0 to 1. So it will be 3 minus 4 plus 6, which will be equal to 5. Okay. So I hope everybody got the same answer. Okay. So that's all for today's lecture.
Thank you, sir.